if the database does go down, how does the application react? Right? Does it throw any random errors? Does it crash everything? Or does it give you proper error messages in the logs which can help you identify? If the database does go down, do you get alerts which will quickly notify you, or do you wait for somebody to call you up? Right? So these are the things that you want to test for, and as a QA you could test this. You have to first, I think the most important thing is defining the various failure scenarios and test scenarios. And then actually testing the scenarios and finding out what happens, right? So another key component of your, so in our case we are using MongoDB with one primary and two secondaries for replication and failover. Let's say what happens if the replication stops happening, right? You think your DB is working fine. Suddenly for some reason this replication is not working and the secondary is out of date. And if at all when you want to do a failover, then you suddenly realize your data is stale, right? So do you have the alerting and monitoring in place to ensure that if the replication fails, then you alert it and you can work on it. So DB backups, right? So we want to do regular DB backups. Maybe there's a cron job which exports a DB regularly, right? But what if the backup is not happening? How do you get notified of it? So then as a QA you could ensure and test that do we have the required alerting and monitoring in place to be notified if the DB backups are not happening. So these are some of the test cases that we wrote, we figured out how to test our database is set up correctly. Moving on, other things could be application performance, right? Like what happens if on production your CPU usage really shoots up, right? And let's say our memory or network need anything. How does the application react? Does it just crash? Do you have anything accounted for it? Right? So some of the tools that you could use, I think Neuralink, Nagios, Ganglia, for ensuring that locality metrics on here. Basically reporting the errors on it. Similar point, how does the system react to database failure? What happens if so you identify different components, right? So database is one component, application, third-party services. What happens if the third-party services go down, right? What happens if the load balancer goes down? And I don't know how many of you have heard of the term chaos monkey, right? This is, service done by Netflix, right? Where there is this tool which will randomly bring down any instance or any environment and check does the application still run? Is it still running? And is it working fine? Logging archive. We often concentrate on most important things, but we forget about logging archive. Are the logs being so yeah, of course logging is happening, but have they been indexed correctly and is your centralized logging working correctly? Right? Log rotate, you have proper log rotation policy in place, is ensuring that the logs are rotating and the lists are not getting full and you're facing issues with that. Right? Application errors. So errors can happen at any time, because system failures or any issues, right? But is your application showing the right error page? Is it logging the right errors in the logs, right? So is it showing a 500, 503 and 404 when it actually needs to be that? For example, one thing that we have is what if there is sometimes you might keep getting small errors, right? But what if there is a sudden increase in the rate of errors, right? Would you be able to realize that? Do you have some alerting in place? So one thing that we have done is if we wanted rate of errors, and the rate of errors go up, then we could report on it and we get an email notification that there is a sudden increase in rate of errors, right? And we could react to that. So again, you could test that, does the application, what happens when you get certain rate of errors, when we get any notifications and alerts and all that. Again, resource consumption usage. So so what you've done is you need to define what is the limits for your resources, and that will be based on your application, right? Every application profile will be different, and you need to define that. Okay, maybe perhaps for my application, I need a warning when it is 80%, but perhaps I need it's critical when it's 95%, right? So you need to identify what are the critical resources your application is using, and then define thresholds and warnings for alerts for it. Some examples of you can see here. This we are using Ganglia to collect metrics for application. This is CPU, network, memory, and load. And you can see over here that around some point in time over here, the CPU is just shot up to 100%. Similarly, for memory usage, you can see that we're touching 4 GB is the total RAM that we have on this box, but it's touching 4 GB quite close to 4 GB. So probably time for a memory upgrade. Similarly, network usage, if you see that this is the network in traffic on this box. And you can see that this is the graph for the last 4 hours, the last day, and you got last week and the last month. And you can see that there are these peaks where it's going all the way till, if you look at the graph over here, it says 40 megabytes per second. That's quite huge, right? So you can see from this graph that, and you can have alerting on this that if the network impression goes much higher than certain value, which will be specific to the application, then we are notified of it and react to it. Third-party services we talked about, alerting on them. I think one of the things that you also want to ensure in a production infrastructure is security testing as well, right? Like, how secure is the application? Right? If it's development environments could be probably a bit less secure, but production environment definitely needs to be very secure, right? So have you configured all the firewalls properly? Every system has admin pages, right? In development environments, more relaxed and everybody can access admin pages, but if you're going live, you don't want the admin pages to be accessed to the public, right? So have you put the restrictions in place and have you tested that it's actually not accessible publicly? So a lot of things that you have to ensure before you actually go live. Caching is, I think, one more thing that you want to ensure that you're tested correctly. Like you're set up proper cache settings, but are they working fine, right? So if you really look at the things that we've gone through here, right? If you really look at it, we talk about things like logging, failover application. If you really look at it, they are nothing but their cross-functional requirements. And in a way, testing infrastructure, if you really think about it, is nothing but testing your cross-functional requirements and ensuring that it's actually satisfied, it's meeting the requirements of the application. We'll show you some small demos of how we go about testing things. So before that, we'll talk a little bit about what Chef is. Chef is just basically the infrastructure automation framework, right, for setting up infrastructure on the cloud. What you see here is a very small example of a simple Chef recipe. This is Ruby code essentially, Ruby DSL. And what this piece of this 10 lines do is basically install the Nginx web server on Node, right? So if you look at it, it starts off with package Nginx, and that one line basically abstracts the installation of Nginx on your box. So based on your host operating system, package Nginx would call either apt-get if it's Ubuntu or Debian, or it will call yum install if it's Fedora or CentOS or Arch. Right? So Chef actually provides you this layer which gives you a good abstraction over your base operating system. Right? Go back to the next one you see here is that I'm defining that the Nginx needs to install as a service. And here I'm defining a template for the Nginx file. If you go to the next one. And Chef actually allows me to templatize the Nginx configuration. Nginx is a web server which I got over, right? And you can see here that I have this is basically like ERB Ruby template. People have used Ruby templating. And you can see on top here that the person is equal to, that's a part which is variable. That's a part which can be parameterized. So you could actually have Nginx running on different ports on different environments. Perhaps on your dev environment, you have multiple Nginx running and maybe all different ports. On Amazon environment, different port, right? So what do you want to parameterize? You could basically parameterize this. You could even have logic like this where if you want basic auth, then you can put an if condition and say putting the directives of basic auth as you want. Alright, so just want to touch upon this point about infrastructure as code, right? So I think that one of the main points has been about treating our infrastructure as code. What does it mean, right? So if you have these scripts which can describe an environment, and it's actually version control, you are basically version controlling your entire environment, right? And if you make any change, you update your scripts, and and that's a new version of the environment which can be rolled out. If you want to create a new environment from scratch, just run these scripts. That can help you ensure that every environment is quite close to exactly similar to each other. We're going to show you some knife commands that we use to typically manage the function. Knife is basically a command line chef utility. So we're going to run commands. So we're going to run commands against the Amazon infrastructure that we have. Right? Let's start off by saying how many environments do you have. So these are the various environments that we have. We got a production, development, QA, and the performance environment. I'll pick up the performance environment and just do a small list of how many nodes we have in that environment. So when I pass -d and an environment name, that gives me the list of nodes in the environment. And let's say I want to look at a specific node. Let's say this is the DB node. Sure. Is it not clear? Is it alright? So I can say live node show and name of the node. That gives me all the details about that node. Right? So if you see, I have built down from environment to a specific environment. And now what is true? So if I want to, let's say this DB has, I want to check if the MongoDB server is running on this box. What I would like to do is probably search onto the box and check the status of the MongoDB process. And I got 3 MongoDBs running on my environment. So instead of searching on each one of them, I can run my knife command here, which will do that for me. So this will be a simple knife search command. Where I say the environment is performance, and the role is DB. And this is the command which will be executed on the remote node, right? Suppose name. So this will actually print out. This will actually execute SH on all the nodes and execute this remote command, which is the hosting node here. So you can see these are the 3 hosts that are configured for DB. And now I want to check what is the status of the MongoDB service running on this. So first is service MongoDB status. That's a MongoDB running. So if you see that command has been executed on all 3 DB servers, right? And I get the status of all 3. So this way I can go about executing remote SH commands, and I can test out various things if I want to test from one place. One more example could be, say I want to look at all my web servers. So I have the role PDB for my web servers, and I have Nginx, the web server running. So this way you can use knife to administer your application. And what you've done is that we noticed that we are using this a lot. So we took it to the next step and we actually we used aspect to organize this. So I will come to that next. This is an aspect file for, let's say, I just created a demo spec file for this purpose. So let's say you're describing your. So one thing to like about aspect test is it helps me specify what my environment is. Right? So if someone looks at this aspect file, this is the specification of my environment. That my environment, I'm specifying a performance environment, which has a live slice, and which has a blue stack and a green stack. This is because we are doing the blue-green deployment on our performance environment, where we have 2 current stacks that could be deployed to. Right? And if you you see that in my blue stack, I'm saying that I have a web layer and I have a service layer. And this is basically a shared example if I used aspect test. Shared examples allow you to reuse test snippets between reuse test snippets, right? And if you see the same test snippet which says web, I'm able to reuse it over here because it will be basically testing the same things in my both my blue and the green stack, right? So this is the high level specification of my environment. And if I go down to each shared example, right? Let me go down to a web shared example. I define the role as web layer, and I have one more shared example which will have a common set of tests. I'll go to the next. But what you see over here is that I iterate over all the nodes for the role, and I run a series of tests for each node. Let's say my web layer has four nodes, right? So if you see the first test that we do is it can connect to the service layer, right? Whether it's got enough, whether it's got network connectivity in place to be able to make a connection to it. Sometimes that could go down and things like that. Whether it can do an HTTP GET, is the node listening on a particular port. We want to check that is our service running as a particular user and as a group, right? We don't want to run the service as a root. So these are the tests which are encoded in here. And if you look at the way we've done this, you say node of this dot should and say be able to connect to, or you say be able to HTTP GET, be running as. So if you see, these are custom matches that we are written in Aspect. Now, Aspect custom matches can be, like, take an example of a few custom matches. So let's say you are writing a custom match for be able to connect to, right? And if you really see what we're doing here, take an example of a few custom matches. So let's say you are writing a custom match for be able to connect to, right? And if you really see what we're doing here is, we execute this command on the remote shell. NC is network connect, which will basically try and check if this target has a port op. Right? Or let's say you want to test if I'm going to do a simple HTTP GET, check the admin is up and running. Right? So we fire in this command which is curl fn and v1. Right? So all these basic tests we have encoded them into our matches. And what this remote command execute does is the same thing as a knife as such, which plus pass as commands and that. So, similarly, we have tests for the service layer. Again, similar things I search, iterate through all the nodes. So, other key things which I want to ensure the service layer is that the service layer is able to talk to MongoDB correctly. Right? And I have this shared example space node connected to MongoDB. And this encodes, encapsulates all the tests which are required for a DB connection. So, I have all my shared examples for. In this case, I'm just doing a simple portrait. So what I do is I iterate over each node which can talk to DB, and I check the connection with each of the three MongoDB servers. One more thing we want to test for is whether your service layer is able to talk to external APIs, right? So if you see, these are the checks for different external APIs. Does any questions about the aspect test, the way you share examples and how this specifies environment and about tests at each level? This still a work in progress. We are adding more tests as you.
I have a question regarding the nodes. So what runs on a node by which you fetch the information? Is it only read or it's a read write?
So all the information is fetched by doing SH command. So if I SH access to the node, then I can do an SH, and so that's what I was showing you so this curl is happening on the node, right? NC is happening on the node. So I'm checking that whether my web layer can talk to my service layer. Right? So I SH on the web layer and fire a command to the service layer. So there's nothing running on the nodes to help me enable this. This is plain SH commands.
And does chef or any puppet, do they provide so I call the node an agent. Any machine as a
in this case, you don't need agents running on the node.
Yeah. But you need SSH.
SSH access you need.
So if it is a Windows box, I need a Windows SSH.
Of course, whatever be the SSH putty or whatever.
And then who will take care of the security aspect? Because these things are all open source. What about the?
No, this is all custom code. I mean, this is the code that we have written essentially.
I'm thinking from a Devops testing perspective that tomorrow we will be thinking about using this code, right? So my first question lies the same that what about the testing those parts? Whose responsibilities with the security aspect of the nodes? Because we are right now reading.
Yeah, I think security. So that they maybe by path I'll come back to it towards the end. Any more questions to ask me? So so we're going to fix some other tools as well. I'll hand it over to Harshad for more.
Yeah, so we had one problem wherein we were having a content delivery network involved and we wanted to test whether it's caching the content as expected. The problem was that we had around 40 domains configured, and each of those domains have caching configured on a content delivery network. And as part of it, what we did, so this is to take around like 2 hours of testing, right? Going through each of those, so we had to set custom headers in the request, and then based on the custom headers, we used to get a specific response from the content delivery network, and we had to verify each of those headers are correct or not. So so this was a gap. This was something that we didn't find any automation around this, and there was no open source code that we could use to test this, and we wanted to automate it. So what we did is we created a gem out of this. It now runs the test in like around 1 or 2 minutes for 40 different hosts, and that's how we were able to. So what I'm trying to get at is so there are a lot of things in this area that are not yet explored, right? There are tools that we could develop potentially, and I think this is something that I would like to emphasize on, that getting into infrastructure testing will really help evolve the tools that are part of that could help us do infrastructure testing as a whole. Yeah, I think that's fine. So QA skills required, right? Some of the things that I have felt personally is that infrastructure testing is completely different than like it's the philosophy is the same, like you have to test, but the technique and the tools that we use in testing infrastructure are completely different. For example, we need to start. We need to have knowledge of different tools and techniques. Tools basically, like command. First of all, you need to be comfortable working with the command line. And you should have some basic shell scripting knowledge. You should be able to foresee issues. So typically, when you think of application, when you have a requirement for a change in application, you would typically know what is expected behavior, right, for this. So for example, a page, right? A page doesn't. There is a text box. The text box. When you enter something in the text box and click the submit button, something should be posted to the server and the database update should happen, right? This is an expected understanding. So this is something that we can actually like. This is something that is known, right? Well known. But when you think of infrastructure, you need to be able to you need to be able to understand what are the different things that are involved in creating the infrastructure in production, right? And you need to test each of those things differently. For example, if there is a database, as Aroj showed you those different test cases, right? So those are the different things you have to think of when you think of testing a database. But when you think of testing a web server, it's completely different thing altogether, right? So the learning curve is is really different than typical application testing. But I think we could start small. Like we could start picking up small things like testing, let's say, a database for instance, learning about it a little bit, and then later moving on to different like firewall rules, security, and all that. So slowly we can move towards more complex configurations. Yeah. So these are some common myths that are about infrastructure testing. So some people believe that there's no need to test infrastructure. Like if it works on a local box, it will definitely work on a production. But as we have seen, right, it's like very complicated. There's so many things, so many systems interacting with each other, network failure, process failure. Like you have to have monitoring and all that to make sure that the infrastructure is working as expected. So second is like application and infrastructure testing strategies are similar. So it's, as I said already, right, it's quite different. You need a different learning. You have different learning curve when it comes to infrastructure testing. Application testing is more important than infrastructure testing. So again, as you saw the third slide, right, wherein there was a different. So application is one part, but there are multiple things involved when it comes to setting up the infrastructure. There aren't too many different things to test in infrastructure. Of course, there are multiple things, right? Like firewall rules, Mongo, like database servers, web servers, content delivery networks, and so on. There is no business value in testing infrastructure. Yes, of course, it's a production infrastructure, right? So of course, there is a direct correlation with the business value that you get out of it. Yeah. So these are some common tools that we have been working, like using. QA should be having knowledge of when it comes to testing infrastructure. So chef, knife, Aroj already gave a demo about it. Ganglia is used for setting up monitoring so the graphs that we showed came from Ganglia. Splunk is again Splunk is a tool to aggregate logs and do some querying around the logs. It's a centralized so it basically enables us to take regular backups of the logs as well. So you don't need to maintain logs on the server. You can do log rotation and then Splunk will take care of the rest. Go is again so in Go you can actually create build pipelines and deployment infrastructure can also be set up in Go. So it's a continuous integration environment basically. Nagios is again used for so Nagios can be used. So Nagios is used for alerting and monitoring. You can set up alerts and send emails or any sort of other alerting can be done using Nagios. Mingle is again Mingle is a tool to track your project development progress. So it's basically ThoughtWorks tool, and we use in Devops for tracking our iteration progress. CacheOff, as I already explained, it's a tool to test caching and content delivery network. Vagrant is used to basically, so Vagrant is basically a virtual box. You can actually create a local virtual box. You can write scripts on top of it using Vagrant to configure the virtual box and provision it as per your development needs. Vim is again, most of us know that it's a tool to edit using SSH or any shell, basically shell. Tmux is basically terminal multiplexer. It is used to create sessions.
Multiple sessions at the same time.
Right.
And then again, SSH is just SSH. Right. So some of the tools are just a small list. Of course, there's a lot more things that really like to listen. Just want to give you a small view of it. And yes, sir, with that we come to the end of our presentation. Do you have time for questions? So, I think we'll take a quick.
So, if you have different environments,